So what is an Azure Cosmos DB? This can be asked in an interview in a different way as well, like explain the functionality of a Cosmos DB. Azure Cosmos DB is a globally distributed, fully managed, NoSQL and relational data service. Please pay attention over here. We are saying it's both NoSQL and relational database service. Normally, a database service is either a SQL or a NoSQL, but a Cosmos DB is provides both. It can provide you an API of both SQL API as well as NoSQL API. A Cosmos DB supports base data model like key value, column, family, document, graph, and SQL. A Cosmos DB is designed to provide high availability and low latency access to a data for mission critical applications and services including e-commerce, gaming, IoT, social media, etc. A Cosmos DB is scaling done both throughput and storage based as your application needs. So in simply terms, you can simply say that either you can scale the Cosmos DB throughput, that is performance, and you can also scale its storage if your application needs more amount of data to be stored. Both the throughput and storage in case of Cosmos DB can be automatically scaled and they can scale individually as well. And finally, a Cosmos DB is having a low cost of ownership because everything is maintained by Azure in default. So simply terms, you can say that a Cosmos DB is a cloud-based NoSQL database offered as a PaaS offering from Microsoft. We already know what exactly is PaaS. A PaaS simply means a platform as a service. So we can say that Cosmos DB is also a PaaS offering from Microsoft. And it again support different models like key value, column, family, document, and graph. And it support both SQL and NoSQL. Now let's move to our next question, that is, what are the features of a Cosmos DB? Cosmos DB provides a rich set of features and we'll discuss these features one by one over here. The first feature that is provided by Cosmos DB is an automated backup. So with the help of Cosmos DB, you can do an automated backup over there. Cosmos DB also provides an automatic failover. So what exactly is an automatic failover? This allows Cosmos DB to failover to the Azure cloud region with the source region became unavailable. So let's say you are having a data hosted on two regions, a primary region, secondary region. So even the primary region is not available due to some issues, maybe some network issue, maybe some natural calamities. The data would be automatically served by the secondary region to your end customer. So in that case, there would be no downtime and the application would be up and running for your end user. So that is termed as an automatic failover. A Cosmos DB also supports an ACID transactions inside it. So whatsoever transaction that are ACID, that means atomicity, consistency, isolation, and durability. These things are automatically supported by Cosmos DB inside it. A Cosmos DB also provides a local emulator for development purpose. So if you're developing an application using a Cosmos DB, you need not to connect to a Cosmos DB or Azure environment all the time. You can just develop it locally, and once the development is done, then you can test it by using an Azure instance. So by doing this approach, you can save a good amount of money. Cosmos DB also support geofencing and geospatial data. So what exactly is geofencing? Is simply means that a Cosmos DB for NoSQL has built-in geospatial functionality to represent geometric shapes or actual location or polygons on map. In other words, you can say that if you provide a latitude and longitude in a Cosmos DB, then it can find out a different locations and different areas around the map that belongs to that latitude and longitude. A Cosmos DB is also having an inbuilt support of link query, so you can directly use link queue with Cosmos DB. And other things in with Cosmos DB are it support ODBC, it supports stored proc and triggers and user-defined functions. So you can create stored procedures, triggers, and user-defined function whenever dealing with a Cosmos DB. A Cosmos DB recycle bin of 30 days. So whenever you delete something for Cosmos DB, it would be remain there for next 30 days. And Cosmos DB also support data encryption both in REST and transit. By REST means whenever something is stored in Cosmos DB that are automatically encrypted. And in transit means whenever you are accessing your data and whenever data is traveling via the wires, it is also encrypted. So even there is no case of man in middle attack. The data that you have used is Cosmos DB would be encrypted both in REST and transit. These are some of the features of Cosmos DB, and if an asked in an interview, you have to explain these features and you have to name them in this way only. Now, let's move to our next question, that is, what are the use cases for a Cosmos DB? A Cosmos DB can be used heavily by an IoT, gaming, and retail that enables high throughput and low latency. It is also used in social media application at it's offered a non-structured data storage, allowing social graph to be created from user-generated data, elastic scalability, which allow easier scaling. So we discussed that a Cosmos DB can be used to store a NoSQL data as well, that is a non-structured data as well. And it can also allow to store a social graph. A graph database is very much useful in a in a social media application where each node is connected to different node. So a graph database is useful, and Cosmos DB provides such functionality that can be used for creating a social media application. A Cosmos DB can be also used to create a highly schema variant app where each new version can be released without worrying about the schema changes. So since it also supports a NoSQL, and since there's a NoSQL functionality, there is no worrying about the schema of the previous record. With the help of Cosmos DB, we can deliver those things and we can create a application that can have these kind of non-schema or schema variant applications. A Cosmos DB can be also used for a geospatial data based on application that involve location-based data such as mapping, navigation, and geofencing. So we already discussed that with the help of latitude and longitude, Cosmos DB creates an application, and with the help of those application, we can find out a different area on the map, we can find out a different navigations, and we can find out a different location based on latitude and longitude. So Cosmos DB helps to find these things. Our next question is, what is Azure Cosmos DB emulator? So Azure Cosmos DB emulator provides a local environment that emulates an Azure Cosmos DB service for development purpose. It can be used for developing and testing your application locally without creating an Azure subscription or incurring any cost. We have already discussed in the past that if you want to develop your application using Azure Cosmos DB, there is no need of connecting your application to directly Cosmos DB environment of Azure. You can download something called as a Cosmos DB emulator, and with the help of that emulator, you can simply create your application locally and can be used for development purpose. By doing this approach, you can simply save a lot of amount of money because, as you know, a Cosmos DB is the platform as a service, and you would be charged as a pay per subscription basis or pay per second basis. Now, for development purpose, as we know that a lot of time involved in developing an application, in that case, there is no worth of paying any cost to Azure. So that's why a Cosmos DB emulator is there, using which you can do your local development in the local environment. Once application is developed and tested using a Cosmos DB emulator, we can switch to using a Cosmos DB account in the cloud. A Cosmos DB prerequisite or a Cosmos DB emulator prerequisite is Windows Server 2012, R2 2016, 2019, or Windows 10 and 11. So this can be asked in an interview as well, like what are the prerequisites of downloading a Cosmos DB emulator? And you can simply say that it can be downloaded, or the prerequisites of having a Azure Cosmos DB emulator is Windows 2011 12, R2 2016, 2019, or Windows 10 and 11. Now let's move to our next question, like how can you compare a Cosmos DB with other databases? So let's try to understand the comparison of Cosmos DB with other databases with the help of this tabular format. We have divided the Cosmos DB comparison into different areas like global distribution, horizontal scaling, latency guarantees, high availability, and data model, and SLA, that is serverless service level agreement. So if we talk about an RDBMS, our RDBMS is not globally distributed, whereas NoSQL is also not a globally distributed. But if we talk about a Cosmos DB, a Cosmos DB presence is having a 30 plus region with multi-homing APIs. A Cosmos DB can horizontal scale both by storage and by throughput independently, whereas a relational database lacks in this functionality. Though a NoSQL databases can also horizontal scale. If you talk about latency guarantees, the Cosmos DB provides this, that 99% of read would be less than 10 milliseconds and write would be less 15 milliseconds. So whenever you read some data from Cosmos DB, 99% of time would happen that you will get a response in less than 10 milliseconds. Whereas if you write something in Cosmos DB, By 99% of time, it would be written in less than 15 milliseconds. Such kind of latency is not guaranteed in an RDMS, while as a NoSQL provides such offering as well. A Cosmos DB is highly available. It is always on and it has a pass-like trade-off and provide an automatic and manual failover options, whereas these things are not available in RDBMS. Again, NoSQL provides such offerings. So you can see that RDBMS lags in multiple areas. It doesn't have a global distribution, it doesn't have a horizontal scaling, it does not have a latency guarantees or high availability. Whereas you can see a little bit comparison between the NoSQL and Azure Cosmos DB. NoSQL also have these things, but an Azure Cosmos DB is something which excels in every of these functionality. Then if you talk about a data model API, relational database is having a relational API, that is you can only write a SQL query. Whereas in NoSQL databases, you can have a multi-model or an OSS API. Whereas in Cosmos DB, it has a multi-model, it's having a SQL and having an OSS API. Though the OSS API is something which is in progress, like it's a beta version is there and more are coming soon. If we talk about an SLA, the relational database provides some SLA as well, whereas a NoSQL database don't have any SLA. While Azure Cosmos DB provides an SLA that yes, there would be some SLA for latency, throughput, consistency, and availability. So if you didn't get a response in that service level agreement time frame, then definitely Cosmos DB will pay you some money in terms of that. So these are the different features that we can compare in terms of an Cosmos DB with other databases. You can see simply that Cosmos DB excels in multiple area against or according to these sections. Now let's move to our next section, that is APIs for Cosmos DB. It can be asked like what are the different APIs that Cosmos DB support. We'll discuss these things in the coming slide. The question could be asked in different way, like how many APIs in Azure Cosmos DB support. Azure Cosmos DB support API for NoSQL. It can support API for MongoDB. It supports API for PostgreSQL. It supports API for Apache Cassandra database. It supports API for Graph database, which is Gremlin. It also supports API for table, that is via Azure Table. You can simply see is that an Azure Cosmos DB provides or supports a multiple API. If you want to create your application using an RDMS, you can simply use a PostgreSQL. If you want to create an application using a NoSQL databases, then Azure Cosmos DB has two offerings. You can directly use a MongoDB instance, or you can use a native instance of NoSQL that is provided by Cosmos DB in default. A Cosmos DB also provides a Graph API which can be used for creating a social media application, and it also provides an Apache Cassandra database API as well. You can see that with the help of a single Cosmos DB account, you can just target your application across multiple flavors of databases, and you can deploy it, you can host it, you can use it, whatever you want, according to different databases. Now, next question is, what is Azure Cosmos DB for NoSQL? The Azure Cosmos DB for a NoSQL is a native non-relational service for working with column or document data model. It stores native JSON document with flexible schema, and data is indexed automatically and available for query using flavor of SQL query language designed for JSON data. It accesses the APIs using SDK for popular frameworks such as .NET, Python, Java, and Node.js. In simple terms, you can say that the Azure Cosmos DB for NoSQL basically a native non-relational service. By native, it simply means that that is something which is implemented by Cosmos DB itself, and it can be used to work with document data model. The data that is stored in an Azure Cosmos DB for NoSQL is in JSON format, and this having a flexible schema. So as we know that in NoSQL databases, there would be no schema constraint. Each and every document can have a separate schema of it, and that is something which Cosmos DB for NoSQL also provide. Each and every document of a NoSQL Cosmos DB database can have a native schema or a flexible schema, and it can be different based on different records. The data that is stored inside Azure Cosmos DB for NoSQL is indexed automatically, and you need not to do anything in order to make it indexed. Like you talk about a relational databases, you have to create indexes in order to create a fast retrieval of data. That is something which is not required in an Azure Cosmos DB for NoSQL. Indexes are done automatically, and they are available for querying using a flavor of SQL query language designed for JSON data. So we can just access the data from a NoSQL Cosmos DB with the help of a query that is designed by Cosmos DB itself. You can write those queries, and with the help of those queries, you can filter the data. The SDK of Cosmos DB is available for popular framework like .NET, Python, Java, and Node.js. So if you want to access an Azure Cosmos DB for NoSQL, you can have a different APIs or SDKs, and with the help of these SDKs, you can interact your Cosmos DB database for NoSQL with multiple frameworks and technologies like .NET, Python, Java, and Node.js. Now the next question is, what is Azure Cosmos DB for MongoDB? As you know, a MongoDB is again a NoSQL offering, and a MongoDB is something which is an independent entity, an independent company. In terms of an Azure Cosmos DB, a MongoDB is a fully managed and serverless database for the application to gain a 99.99% availability worldwide, elastic scalability, and automatic sharding. So whatsoever MongoDB feature provide individually, that features are also provided by the Azure Cosmos DB APIs for MongoDB. So technically, we are using an MongoDB itself with the help of Azure Cosmos DB, and they have some kind of party collaboration. Like both the organization has come together and they have created a API. And using those API, if your application are using a MongoDB, you can directly leverage the functionality of cloud, and you can leverage the power of Azure to create our application with the help of MongoDB, and you can use an Azure Cosmos DBI for it. This API enables easy development of MongoDB databases with few code changes and continued using MongoDB drivers, SDK, and tool. And that is very much important. Like suppose if you're using a MongoDB database on your application and now you want to move a cloud native solution, you can simply use a MongoDB drivers, SDK, and tool, and you can keep using your application databases with the help of an Azure Cosmos DB APIs. A Cosmos DB API for MongoDB implements the wire protocol from MongoDB, which allows a transparent compatibility with MongoDB client SDK, drivers, and tool. Azure Cosmos DB does not host the MongoDB database engine. So that is something which you need to remember. A Cosmos DB does not host a Mongo database engine. That is something which is managed by MongoDB as an individual entity itself. Azure Cosmos DB only provides an API or an SDK using which you can interact with your MongoDB instance. I'll again repeat that a MongoDB is a separate entity, and this Azure Cosmos DB and MongoDB has come into a collaboration to provide an API. With the help of those APIs, you can interact with your MongoDB database instance. It is recommended if you have existing MongoDB workload that you plan to migrate to Azure Cosmos DB. Again, as mentioned earlier, if you are already using a MongoDB and if you want to do a cloud native application or you want to migrate to a Cosmos DB, in that case, we can use this Azure Cosmos DB for MongoDB APIs. Now let's move to a next question, that is, what is an Azure Cosmos DB for a PostgreSQL? Native PostgreSQL is a globally distributed relational database that automatically shards data to help build highly scalable application based upon Citus. And Citus is a Postgre extension that transforms Postgre into distributed database so we can achieve a high performance at any scale. We can start building application on single node server group in the same way that we are been doing using a PostgreSQL anywhere else. And as the app scalability and performance requirement grow, it can be seamlessly scaled to multiple node by transparently distributing data to your table. Now you again see that a post, likewise the MongoDB, a PostgreSQL is also a separate entity. And again, an Azure Cosmos DB and PostgreSQL comes into a collaboration, and they have exposed an API. You can simply use a Postgre database in your, if you're using a Postgre database in your application, and if you want to migrate to a Cosmos DB, you can use this API and can start using these things. And with the help of the Azure Cosmos DB API, you can simply access your Postgre database. You can simply store data over there. And the functionality is that it can scale as well depending upon your application requirement. Our next question is how Citus is helping the Azure Cosmos DB for PostgreSQL. So in order to understand this, first of all, we need to know what exactly is a Citus. A Citus is a PostgreSQL extension that transforms Postgre into a distributed database so that we can achieve a high performance at any scale. With the help of Citus, we can make a PostgreSQL a very advanced database, and it is capable of handling a large transaction throughput, specifically in the multi-tenant app. It can run a fast analytical queries, and it can process a large amount of time series of IoT data for real-time analytics. So with the help of Citus extension in the Postgre, we can achieve these tasks. Now, let's understand how Citus is helping in Azure Cosmos DB for the PostgreSQL. So with the help of Citus database, the cluster grows from a single PostgreSQL node into cluster by adding a worker nodes. In a Citus cluster, the original node to which the application connect is referred as the coordinator node, and the Citus coordinator node contain both the metadata of distributed table and the reference table, as well as local table and sequence to other database object and a foreign table. So you can simply say that the Citus coordinator or the Citus extension basically can be helped to include any worker node in the PostgreSQL extension, and it also helps us to connect with both the metadata of distributed tables and the reference table. So it could be a regular local table, sequences, and other database object. This, whenever you run this query in an Azure Cosmos DB for PostgreSQL, with the help of Citus coordinator, it can redirect query to different worker, and with the help of those worker, you get a fast performance or the fast retrieval of answer or queries response from them. Now, the next part is data is distributed table is stored in shard, which are actually just regular Postgre table on the worker node. And when querying a distributed table on the coordinator node, Citus will send the regular SQL query to the worker node. That's the way all the usual PostgreSQL optimization and extension can be automatically used with Citus. So in simple terms, you can say with the help of Citus, we can perform a various of operation in the Azure Cosmos DB for PostgreSQL, and it also has a concept of a worker node. And the Citus coordinator, which is defined over here, with the help of this Citus coordinator, it can direct all the different queries to different worker node, and in short to different shard, which helps in the faster retrieval of data. So this is all about a Citus in a PostgreSQL. What is the Azure Cosmos DB for Apache Cassandra? Before going to that topic, let's discuss what exactly do you mean by Apache Cassandra. Apache Cassandra is a highly scalable, high performance distributed database designed to handle large amount of data across many commodity servers. It provides high availability with no single point of failure. With the help of Azure Cosmos DB, you can run an Apache Cassandra database as a fully managed and globally database service in the Azure cloud. This service combines the capability of Apache Cassandra with the benefit of Azure Cosmos DB, such as global distribution, automatic scaling, multi-model support, which make it easier to build and deploy Cassandra-based applications that require a high availability and a global reach. We can simply say that the Azure Cosmos DB for Apache Cassandra is a combination of the capabilities of Apache Cassandra with the benefit of Azure Cosmos DB. The Azure Cosmos DB for Apache Cassandra also enables the interaction with an Azure Cosmos DB with the Cassandra query language that is also called as CQL. And with the help of Cassandra based tools like CQLSH and existing Apache driver compliant with CQL version 4. With the help of Azure Cosmos DB, we can use an Apache Cassandra and we can leverage all the benefit that is provided by Apache Cassandra, and it can also automatically scale, have a multi-model support, and so on. Now let's move to our next question, that is an Azure Cosmos DB for an Gremlin. What exactly is Gremlin at the first place? Azure Cosmos DB for Apache Gremlin is a graph database service that can be used to store massive graph with billion of vertices and edges. It allows user to make graph query and store data as edges and vertices, and combines the power of graph database algorithm with highly scalable and managed infrastructure. This also provides a unique and flexible solution to common data problem associated with the lack of flexibility or relational approaches. The API for Gremlin is based on an Apache Tinkerpov graph commuting framework, and the API for Gremlin uses the same graph query language to ingest the query data as used by Gremlin database. The API for Gremlin also works with Apache Graph and Graph Frames. So as we just discussed that a graph database basically stores data in the form of edges and vertices, so it makes it a best suited for creating a social media application. In social media applications, it is required that you connect one person to multiple other person, and a graph database is best suited for those scenario where you want to track a person from one to its lower child. The Azure Cosmos DB for Gremlin basically combines the graph database algorithm power with providing a support of a Azure ecosystem, which is highly scalable and managed infrastructure. It also provides a very unique solution to a problem that is lack of flexibility, the problem which is associated with the lack of flexibility in relational approaches. One question that also can be came over here, that what is the computing framework for an Gremlin API, and the answer is Apache Tinkerpop. So Apache Tinkerpop is the computing framework for an API for Gremlin. The API for Gremlin is also work with Apache Spark and GraphFrame, which is basically used in the case of a big data processing queries. So this is all about an Azure Cosmos DB for Gremlin. Now let's move to our next question, that is an Azure Cosmos DB for table. So what exactly is an Azure Cosmos DB for table storage? The Azure Cosmos DB for table API basically stores data into a key value format, and it offers a low latency, auto scaling, high throughput, global distribution, and better index management for highly query performance. In simple words, you can say that an Azure Cosmos DB for table stores data into a key and value format. So you do have a key, you have a value, and that in combined called as a table in context of Azure Cosmos DB. The application that is written on an Azure table storage can migrate to the API for table with little code changes and advantage of premium capabilities. So in case of Azure storage account, we do have a concept of Azure table storage, and the applications which are built on the Azure table storage can easily be migrated to use an Azure Cosmos DB, so that it can take advantage or the fully advantage of all the capabilities that is provided by Azure Cosmos DB, that is multi-region support, highly scalable, and so on. Our next topic is Cosmos DB Data Engine. So let's discuss what exactly Cosmos DB Data Engine is and how it works internally. The first question that can be asked around this topic is how Cosmos DB Data Engine work. The Cosmos DB Data Engine is based on Atom Record Sequence, that is ARS. A stands for atoms, which consist of primitive types, example string, bool, number, etc. R is records, which are basically structs, and S is sequences, which consist of array of atoms, records, or sequences. A Cosmos DB data engine is capable of efficiently translating and projecting all the data model into the ARS based model. In simple terms, you can say that whatever data you present to Cosmos DB in the form of your data model, internally that is converted into the ARS based model by Cosmos DB. This is accessible from all dynamic type programming language like C#, Python, Java, and can be exposed as is using JSON and other similar representation. It can be asked in an interview like what are the different type of representation that an ARS model can be presented. The ARS model can be presented in JSON and any other similar kind of representations. It natively supports proper database API for data access and query. So all the popular APIs, as we have discussed, that Cosmos DB support for Gremlin, for MongoDB, for PostgreSQL, all the different APIs are supported by Cosmos DB, and it can be used for data access and query. Now let's move to our next question, that how Cosmos DB data engine maps various databases. Let's try to understand this with the help of a structured diagram. So over here you can see that in the left hand side we have something called as ARS, which is the atom record sequence. Now what exactly is ARS we have just discussed in the last slide. In the ARS we have something called as container. A container basically can have any item, can have anything, and over there we project it to different collection. So if we are using a MongoDB, we project the ARS into collection format. If we are using a Gremlin DB, we use it in a graph. If we are using a tabular format, then we use a key value pair. Similarly, if we talk about an item inside a container, if it's a MongoDB, then it's called as document. If it's a table, that is a key value pair. And in case of a Gremlin DB, it's basically a vertices and edges. So this is how our data is mapped inside a Cosmos DB across various databases. Our next question is, what is database, containers, and items in Cosmos DB? So let's discuss this point one by one. The first point is database. A database is a logical container that holds a set of related container and user defined functions and triggers. A database are used to group related data together, and each database can have a multiple container. In simple terms, you can say a database is a collection of different container, and it also consists of UDF and triggers. A container are used to store and manage the actual data. A container is equivalent to tables in RDMS or collections in NoSQL database. So we have understood that if you talk about an RDBMS like SQL Server or Oracle, we store data into a table. And in case of NoSQL like MongoDB, we store data into collection. So in the context of Cosmos DB, which is basically a SQL and NoSQL both, a container is basically called as a area using which you can store and manage the actual data. It's similar to tables in context of RDBMS and similar to collections in context of NoSQL. A container can have items, and item are the individual pieces of data stored within the container. A item is equivalent to row in a table or document in a NoSQL database. Again, inside a table in RDBMS, we have rows which consist of exact pieces of data. The items in case of Cosmos DB are equivalent to rows in case of RDBMS and document in case of NoSQL DB. So you can relate the Cosmos DB concept with the concept of RDBMS and NoSQL. As a thumb rule, we can say that a database consists of multiple container and database contain a group of user-defined functions and triggers. A container is equivalent to tables in RDBMS and collections in NoSQL. A item is basically something which is inserted inside a container, and an item consists of a row or a table in or a document in NoSQL database or a row or table in context of RDBMS. So this is all about database containers, database and items in Cosmos DB. Now the next question is, can you use a third-party tool to query a Cosmos DB? Yes, we can use third-party tool like Azure Synapse Analytics, Power BI, and any other tool that supports SQL querying to perform analytical query on data stored on an Azure Cosmos DB engine. Let's move to our next topic, that is Cosmos DB partitioning. Let's discuss what do you mean by a Cosmos DB partitioning and how it works. The first question that can be asked around this topic is, what is the partitioning of an Azure Cosmos DB? The partitioning is the process of dividing and distributing data into multiple physical partitions. By doing partitioning, we make data as self-contained unit of data that is distributed across underlying infrastructure for scalability and performance. In simple terms, you can say that we do partitioning in Azure Cosmos DB so that our data could be distributed across multiple partition, and thus it helps in the querying of data easily. As in this example, we have created a partitioning key as airport, and we have seen that the three different partitions are created depending upon the airport name. So all the record that belongs to airport lags will go inside this partition. Similarly, all the record that belongs to airport AMS will go on this partition, and all the record that belongs to airport MEL that goes into this partition. This is how the partitioning of Azure Cosmos DB work, in which we create a different partitions, and those partitions are consisting of a data of a particular set. Now let's move to our next question, that is, what is horizontal partitioning in Cosmos DB? In terms of horizontal partitioning, all the resources are horizontal partitioned. The same example that we have seen in the last slide can be used over here as well, in which we have divided all the different partition based on the airport name as the partition key. The partitioning of the horizontal work in a different way. So it worked on implemented at tenant level, that is collection, graph, and table. And resource partition is consistent, highly available, and resources are governed. So whenever do these kind of partitioning, we simply make our data more flexible and scalable, and the performance of data would be high. Now let's move to our next question, that is, explain the global distribution in Cosmos DB partitioning. If you talk about global distribution, all the resources are vertically distributed. We can understand this with the help of an example. So in this example, you have seen that the partition is again the airport key, but over here, the data is distributed globally. So the we can see this with the help of a graph. The read and the reads and the write. So in case of, again, the data is distributed on the partition key, which is airport, but further down the line, the data is further distributed for separate read write operation. So over here, you can see that if you're doing a read write, that is coming from this partition. But if you're only doing a read, then that is coming to the other two partitions. We can say that we have further modified the data, or we have further distributed the data into multiple partitions, so that in case if we only want to read, we will not go inside this partition, and this partition will be only responsible for writing a data into a Cosmos DB. A partition on a global level is done with the cluster, data center, and region. And again, this is one of the way in which we can make our data available across all the region, and we can increase or improvise its performance. Now let's move to the next question, that is why partitioning is important in an Azure Cosmos DB. It can be asked in different way as well, and can be asked like what are the importance of partitioning, or explain the advantages of partitioning in Azure Cosmos DB. The first advantage of having a partitioning is it's essential for distributing data and workloads efficiently. It also allows Azure Cosmos DB to scale horizontally by dividing data across multiple server or nodes, ensuring high throughput and low latency for read and write operations. So, as the advantage of partitioning, we can say that whenever we do some kind of data partitioning in Azure Cosmos DB, the first and the foremost advantage is that we essentially we distribute the different workload efficiently, and the second advantage is that we allow Cosmos DB to scale horizontally by distributing data across multiple servers and nodes. And by doing this, we enable a high throughput and low latency. Now let's move to our next question, that is, what is partition key and how it is chosen in Cosmos DB? A partition key basically is a property within the data set that we specify on the basis of partitioning. It determines how data is distributed across physical partitions, and choosing the right partition key is critical for an optimal performance of an application. We should have partition key divided in that way that it avoid a hot partitions. So what exactly we mean by this and how a partition key is divided? Let's say if you are having an employee table, and an employee consists of two or multiple records, but majorly the records are divided into two different categories, a male employee and a female employee. Then you can use this gender key as a partition key of your employee dataset, so that all the employees that are male would be living on or would be having in the one partition, and all the employees that will be female, the data would be separate partition. By doing this, whenever you want to filter out a male employee, you will simply remove half the record to be searched that are females. So that's why it is very much important to have the correct partition key chosen for the Cosmos DB, and that is something which can be chosen as per your business use case. Now let's move to the next question, that what are the considerations when selecting a partition key? And again, this can be asked in an interview because a partition key is very much important topic in a Cosmos DB. The first point that you should consider of having a partition key is named as cardinality. It simply means that we should choose partition key that have high number of distinct value to ensure even data distribution. Likewise, in my previous example, when we're talking about a gender as male and female, since male and female are two distinct value in the entire result set, we should choose that as a partition key. The second is query pattern. We should also search for a query pattern, like what exactly we are querying in Cosmos DB before creating a partitions. If we create a partition based on query pattern, then we'll get the desired performance from a Cosmos DB dataset. The third is scalability. We should also consider this into consideration whenever we want to choose a partition key in case of Cosmos DB. It ensures that the partition key allows for horizontal scaling without creating any hot partitions. Now the next question is, how does Azure Cosmos DB automatically manage partitioning? Azure Cosmos DB automatically manage partitioning on the base of chosen partition key. It dynamically splits and merges partitions as data volume grow or decrease to maintain an efficient data distribution. In simple words, you can say that the partitioning in Azure Cosmos DB is something which is done internally, and it relies on the key that we have chosen as the partition key. It automatically split and merge different partition as data volume grow or decrease to maintain data as an if distributed efficiently across different partitions. Our next question is, what happens when you change the partition key of an existing Cosmos DB container? So whenever you change a partition key of an existing Cosmos DB container, it is a very complex operation and it typically requires a data migration to a new container. These things should be done carefully to minimize disruption. In simple words, we can say that a changing of partition key of an existing container is not a good idea, because if you want to do this, you have to migrate all the data to a new container. And once data is migrated, only after that you can perform this activity. Now let's move to our next question, that is, can you have a multiple partition key in the same Azure Cosmos DB container? It can be asked in a different way as well, and can be asked like this. Can we it is possible to have a multiple partition key? The answer is no. A single Azure Cosmos DB container can have only one partition key. The key is used for distributing data across physical partitions. So that's why we cannot create a multiple partitions key in the same Cosmos DB container. So this is all about Cosmos DB container and its engine. Our next concept is Cosmos DB consistency level. Let's discuss what do you mean by consistency level in Cosmos DB. But before going to that part, we have to understand what do you mean by a consistency level. So we know that a Cosmos DB is a multi-region database, which means you can write a data into Cosmos DB across multiple regions, and the applications that are using that data across multiple regions will be able to access the updated value. Now, if we want to access data across all the region without any order loss, we must consider that there would be some latency between data write and availability of the data in the same region or across another region. Let's try to understand this with the help of an example. Suppose right now I am on region 1 and this is region 2. I have hosted my application on both the regions. So we can say as first region and this as second region. Now, if I perform some operation on the first region, let's say I updated a value as 2 to a particular field. Now, Cosmos DB or Microsoft internals will take some time to sync data from region 1 to region 2. And the application that are using or the user that are accessing the region 2 will get the latest updated value of that particular record, that is 2, in front of the web page or whatsoever application they are using. Now, there would be some latency in which a data is replicated from one region to another region, and Cosmos DB provides us a different consistency level using which we can set that latency. We can just have a trade-off between latency and throughput, and depending upon business use case, we can set that level. The Cosmos DB in Azure provides a 5 different type of latency. The first one is called as strong. The second is called as bounded staleness. The third is called as session. The fourth is called as consistent prefix. And fifth is called as eventual. The one that is mentioned on the left provides a low latency, whereas the one on the right provides a higher latency. Low latency means high availability and better read scalability. So we'll understand this strong, bounded staleness, session, and consistent prefix in the next slide. But from this slide, as an interview perspective, if someone asks like, what do you mean by a consistency level in Cosmos DB? Then you have to answer these 5 points. That Cosmos DB supports a 5 different type of consistency level, that is strong, bounded staleness, session, consistent prefix, and eventual. Now let's move to a next slide in which we will discuss these level in detail. So let's discuss the first part, that is strong. So if we use a strong consistency level, it simply means that the reads are guaranteed to the return of the most recent version of an item. As the name suggests, it's a strong level. So whatsoever data you read, it would be the most latest one. And when I say read, it simply means that read across all the different regions. So let's say in the region 1, I updated a value of a particular record to 1. As soon as I read the value in region 2, the value would be 1 as well. So there would be a concept that if we're using a strong consistency level, then the read guaranteed are the recent one. The second is bounded staleness. A bounded staleness is basically a consistent prefix and it reads lag behind the write at the most k prefix of t interval. So when we say bounded staleness, it simply means that the read and write, there would be a delay between the read and the write, and the delay would be constant. It would be by k prefixes or t interval. So let's say we can hypothetically we can assume that with the help of bounded staleness, we can say that data in region 1 would be replicated the data into region 2 at an interval of consistent 3 seconds, which means that a data from region 1 will be updated to region 2 after 3 seconds. This is called as bounded staleness. The third part is called as session, which is again a consistent prefix, which means a monotonic read and monotonic write, or read or write, or write follows read. It means there would be some session consistency across the different client. The fourth is constant consistent prefix, which means that read never see out of order write. If writes were performed in the order ABC, then client either see A, or ABC, but never out of order like AC or BAC. Let's understand this in detail. So if we set the consistency level as constant prefix, we are mentioning that there would be a guarantee in the order. So if the writes are A, B, and C, then client can either say AAB or ABC, but it will never see the record C before record A. So there would be a guarantee in the sequence of it. And the last one is eventual, which simply means that out of order read. It's about a Cosmos DB or its internal architecture, like how data would be read or displayed across multiple regions. But if we are using an eventual consistency level, then all the write and read operation would be an out of read sync. Now these are the 5 different kind of consistency level that is in all Cosmos DB. Let's try to understand the consistency level of Cosmos DB with the help of an example. So let's say we are discussing about a baseball game score and there are two teams named as a visitor and a home, and the visitor team scored 2 runs and a home scored 5 runs. Now let's see what exactly the data would be displayed to an end user according to different consistency level in Cosmos DB. Since we have discussed the strong level provide the most updated write operation, so in that case a 2 by 5 is displayed to the end user in terms of visitor and home. A bounded staleness will display a record after a couple of intervals or inning. So that's why you can say that there is something a consistency around this, that is 2 3, 2 4, and 2 5. The session is basically for a single session you will get a same value. So you can say there are a couple of other values as well, 0 0, 0 1, 0 2, 0 3, and so on. So with the session output, you can simply say that a different type of data can be displayed to the end user depending upon its current session. Consistent prefix is something we should discuss, that there would be a regular interval write operation or read operation, but there would be exact prefix. The way the data write would be displayed to the end user. Over here, you can see that the first is 0 0, which is this and this, and then 0 1, and then 1 0, and so on. And the final is eventual, which simply means that it will display in any order and it will not follow any particular sequence. So you can say that with the help of these examples, we can understand what are the different consistency level in case of an Azure Cosmos DB. Our next topic is Cosmos DB scaling. So let's discuss how a Cosmos DB is scaled in case of a throughput or high workload is required. The first topic in this context is request unit, or what is RU in Cosmos DB. An Azure Cosmos DB normalizes the cost of all database operation using request unit, which is also called as RU for short. A request unit is a performance currency abstracting the system resources, that is CPU, IOPS, and memory are required to perform a DB operation supported by Cosmos DB. In simple words, you can say that a request unit is a way to measure how many resources such as CPU, input output, and memory is required to perform a particular operation. A one request unit equals to read 1 KB of item with 10 unique properties. It's a as mentioned, it's a combination of memory, CPU, and IOPS, and it is calculated by Azure ML. So Azure ML is responsible for calculating the request unit whenever you try to interact with your database using Azure Cosmos DB. The request unit, like how many request unit would be charged, is something which is calculated by Azure ML, and it also provides a Cosmos DB capacity calculator. So, for an example, we can try to understand how a different things or how a different request unit can be charged in Cosmos DB with this tabular format. So, if an item size of 1 KB and if you do 500 reads and 100 write per second, then there would be 1000 request unit charge. Similarly, if an item size of 1 KB and if you do 500 reads and 500 writes, then you can see there is a tremendous increase in the request unit, because right now the writes were 100 and the request unit 1000, but right now over here the writes are 500 and the request unit will be 3000. Again, you can say that if reads are 500 and writes are 100 and the size of 4 KB, then request unit would be 1350. Whereas if the size of 4 KB, if a read and write are both 500, then the request unit is 4150. So you can imagine a pattern over here, that whenever the writes per second is going ahead, the request unit is also increasing. The writes per second is directly proportional to request per unit. It's always, since the Cosmos DB supports a multiple region database, so that's why whenever you write a database or write something into database, that is replicated across all the different region of Cosmos DB, and that include a good amount of cost. So that's why you can say that for a same item size, if you only do a read, you will have to pay a less amount as compared to if you do both read and write operation. So this is all about a request unit in Cosmos DB. Now let's move to the next question, that is, what is scaling in Cosmos DB? Scaling simply means increasing the number of request unit. The Cosmos DB support two type of scaling, the scale up and scale down, and scale out and scale in. So when you say scale up and scale down, it simply means that you increase or decrease the number of RUs. But when you tell scale out and scale in, you means you increase the number of partitions for your collection graph and table. This concept is quite similar with the other Azure scaling part, that app services, in which we also increase number of resources as well as and increase the number of hardware in the particular resource. So scaling up and scaling down is similar to everything in Azure ecosystem. The first one will increase the number of RUs and the second will increase the number of partitions. What is the elastic scalability? Now, this is a question that can be asked in an interview in Cosmos DB. And what does it exactly mean? The elastic scalability simply means an automatic mechanism by which a resource are scaled up or scaled down based on the workload increase or decrease. It allows you to easily and dynamically adjust the throughput and storage capacity of a Cosmos DB database to handle various workload, high demand, or changing application requirement without incurring a downtime. In simple words, this elastic scalability is the mechanism in which a resources can be scaled up and scaled down, and that is not limited to a Cosmos DB. You will find this term across entire cloud ecosystem. With the help of this elastic scalability, we can easily dynamically adjust the throughput and storage capacity of a Cosmos DB database that can handle various workload, high demand, or changing application requirement, and everything that is does not have any downtime, which simply means that your application would be up and running, there would be no downtime, your client will not face any issue while accessing your application. This is all about an scaling part of an Azure Cosmos DB. Our next topic is NoSQL API query. In this, we'll discuss our different questions that can be asked around the NoSQL API part. The first question that can be asked is explain the Cosmos DB hierarchy for NoSQL. It can be asked in different way as well, like what do you understand by the Cosmos DB hierarchy? The Cosmos DB hierarchy is divided into following category. The first one is document DB, which is basically the root. So once you log into a Cosmos DB, you will get a databases inside it. The first is user database and then permissions. The permission is used to maintain different permissions that are associated with a Cosmos DB. Inside a database, you can have collection, a collection and can have a document. So let's say if you are working on an employee collection, the employee would be a collection over here and a employee ID would be a document inside the collection. A collection can have a stored procedure, it can have triggers, it can have user defined function. So as you can see, the Cosmos DB is capable of creating and executing all these different kind of stored procedures, triggers, and functions. We'll definitely discuss in detail how can we create a stored procedure, a function, and UDF in Cosmos DB. But from this slide perspective, you have to see that a collection inside a collection, a stored procedure, a triggers, and UDFs are created. Then in the document section, we can have certain attachments as well as required. So this is the whole hierarchy of a NoSQL API for Cosmos DB. Now let's move to our next question, how to create a stored procedure in NoSQL API. So in order to create a stored procedure, you have to write something like this. The first thing which you need to make sure that the query or the code that we write in a NoSQL API for Cosmos DB is based on JavaScript. JavaScript is the primary language for Cosmos DB interaction in order to create a stored procedure, triggers, or your defined function. In this example, you can see that we have created a function named as getDocs, and then we have taken some context or something from the Cosmos DB context. And finally, we are creating a stored procedure over here in which we are querying the documents, and based on certain condition like select star from container, we are returning a data from it. In a similarly way, in the next slide, let's discuss how to create a stored procedure for insert in Cosmos DB. Again, for insert, you have to write a JavaScript code, and you have to first of all took a context references, and then the main condition is container.create document. So in order to write an insert statement, you have to use container.create document, and in order to write a select statement, you have to use container.select document. Now let's move to our next part, that is how to create a user-defined function in NoSQL API. In order to create a user-defined function, you have to use or call the function based on JavaScript, and then you have to use it like this way: select start, select UDF dot function name, and have to pass the parameter to get a user-defined function value.